All right, today we are doing 10.4, perimeter and area of similar polygons. So perimeter, if you don't remember, is the adding up of all the outside edges or walking around the outside of a shape. So adding all sides of a shape. So an example here, if I drew a shape, let's say something like this. Let's say this is 2, this is 3, 6, 4, and 4. Your perimeter would be adding all of those up. So your perimeter would be 19. And similar polygons, this is also a review, but they're the same shape but a different size. It's like a circle, but one bigger than the other. So your same shape, different size. Two things have to be true. All the angles have to be congruent, and all the sides have to be proportional. So some examples here. You could do like a triangle like this and a triangle like this. Those would be similar because they're the same triangle. Or do a small square and a big square. Those would be similar. But something like this, a right triangle and another triangle, would not be similar. And then a scale factor is just the ratio of corresponding sides. So your ratio of corresponding sides. Of similar polygons. So if we draw two rectangles over for the example, for 90-degree angles, so all of our angles are the same. Say this side is 2 and this one is 5. This is 3 and this is 7.5. So your scale factor is going to be the ratio of the two sides. So if I take this 2 and this 3, I can write down the scale factor is 2 over 3. And you can also type it in and get a decimal, but you don't have to. So that would be the scale factor. So a note here, I'm going to ignore this one. If we label this 8, 4, 12, and 6, we'll say this is 1 and this is 2. If I do a ratio of the perimeters and simplify that down, so if we find the perimeter of our shape 1, we're going to do 8 plus 8 plus 4 plus 4, and you'll get 24. And I'm going to put that over, here, let me change this here, we're going to do perimeter 2 over perimeter 1. So perimeter 1 is 24. Here, if you had 12 plus 12 and then 6 plus 6, you get 36 for the perimeter of shape 2. If we simplify this down, you're going to get 3 over 2. If I do the same thing with the areas, so area 2 over area 1, you're going to get 72 over 32, coming from 8 times 4, and then 12 times 6. Simplify this down, and you're going to find 9 over 4. So how that relates, if you have a scale factor, the ratio of the perimeters is going to be that same scale factor, and the ratio of the areas takes that scale factor and squares everything. So how do we use that? So here, if we have this example, we have two trapezoids. We know one side length is 6 and one side length is 9. So we can find the ratio of the sides. If we call this 1 and this 2, do 6 over 9 will give us 2 over 3 for our scale factor. So in the ratio of the perimeters, it's going to be the same way. Here we want smaller to larger, so we want the smaller on top. So it's still going to be 2/3. And then to find the ratio of the areas, you want to square those. So you end up getting 4 over 9. So here, is another type. Here we know the area of the smaller pentagon is 27.5 centimeters. We want to figure out what's the area of this bigger pentagon right here. So this is our small one, this is our large one. So we're talking about areas, so we want area, say the small over area of the large has to equal our a squared over b squared. So you want to start by finding the scale factor. So your scale factor here, we could do 4 over 10 would give you 2 over 5. And we're going to take that and plug that in over here. So we know the area of the small shape is 27.5. We don't know the large one. And then our scale factor is 2 over 5. So you can do 2 squared over 5 squared here. And then at this point, you just need to solve. So you can cross multiply like we've done before. And you will end up with 4 times the area of a large shape is going to equal 687.5. Then divide by 4. And the area of your large shape should be about 117.875 centimeters squared. So here's another example. Take a minute to do it on your own, and then we'll talk about the answer. Okay, so this one gives us the scale factor is 3/4. We know the area of the larger one, so the bottom, because 4 is on the larger, is 96, and we want to find the area of the smaller one. So area of our smaller one we don't know. The big one is 96, have to go over 3 squared and 4 squared. So cross multiply, you get 16a, or the area of your small one. And then here we get 9 times 96, or 864. Divide by 16, and you should get 54 inches squared. All right, another example. So here, 2 triangles are similar. We want to figure out what is their scale factor. So this is giving us the opposite thing. So it gives us the 2 areas. We want to go backwards and find the scale factor. So we know that a squared over b squared has to equal the areas. So if you do 50 over 98, at this point, start by simplifying. So I can divide both of these by 2 and get 25 over 49. So I'm at a squared over b squared equals 25 over 49. So if I want to get to just a over b to get the scale factor, I'm going to take the square root of both of these, like this. And you'll end up getting a over b equals 5 over 7. And that will be your scale factor, and that's also the ratio of perimeters. So the very last example is kind of a word problem. So the scale factor dimensions of 2 similar pieces of window glass are 3 to 5. So it gives us the scale factor. We know the smaller piece costs $2.50. You want to figure out the larger piece. So we can set this up of 3 over 5. And then the smaller piece was $2.50 over our larger piece. So do whatever you want with this. We'll say A2. Cross multiply. You get 9 as your area equals 62.5. Divide by 9. And your area is going to be 6.94, or money in this point. All right, so that's it. Here is an optional assignment if you like to do it. You can also do the 10.4 Math Excel if you would like.